So what we're going to do now is have a look at the conservation of momentum in terms of explosions rather than in terms of collisions, which is what we've been looking at so far. So what are explosions? Well, in terms of physics, they can be anything that you might think. When you think of explosions, you might think of fireworks. As they shoot up into the sky, they're going to explode apart into lots of different fragments. And so it starts off as one object and it goes into lots of different numbers of objects. And you might think of a bomb, for example, which will explode again into lots of different fragments. But also, apart from that, you might not have thought that explosions could be controlled, like for example with a space shuttle or a rocket that's being launched. And even in this case, the object starts out as one, so the fuel is contained within the rocket, so you can consider it all as one single object. But once the fuel begins to burst out and move downwards, then the object is becoming separated. So the rocket has to move upwards to conserve momentum. So explosions are anything that involve one object becoming many objects. It's the opposite to a collision where, remember, we had two objects coming together to form one object and then moving off together as one whole thing. So an explosion can involve a release of energy resulting in particles flying apart. For example, a rocket uses a controlled explosion. The rocket is forced upwards as the gases are forced downwards. The change in momentum of the rocket is equal and opposite to that gained by the gases. I think it was 2009 when I went to see the space shuttle launch from Cape Canaveral, and it was one of the greatest things I've ever seen. Even though I was 6 miles away on the platform, the causeway, which is the general viewing part, it was one of the greatest things that I've ever seen. You could feel the shockwave from the launch, and you could see the space shuttle go up into the sky for probably about a quarter of an hour, and all the people, the atmosphere was just fabulous. So let's have a look at how we calculate. We're using an example calculation here, how we use the conservation of momentum idea when we're looking at explosions. So when you fire a rifle, of course you've got the bullet inside the gun, right? So the bullet and the gun can be considered as one whole object. And as soon as the shot is fired, of course the bullet leaves the gun, so that one object is now separated into two objects, the bullet and the gun. They're no longer physically in contact with each other. So in order for the bullet to be able to be given a force that moves the bullet, that accelerates it from nothing, from 0 meters per second to a fast velocity, then it's got to have a force exerted as a change in momentum. And that change in momentum can't come from nowhere. There's got to be a change in momentum of the gun as well in the opposite direction in order to conserve the total momentum. So the total momentum at the start is actually 0 of the whole system. Nothing's moving. So to go from nothing to something, there needs to be a balance. So let's see how we can use our normal equation, our familiar equation of momentum equals mass times volume, P equals mv, in order to solve this problem. So the problem is a bullet of mass 0.01 kilograms, that's 10 grams, is fired from a rifle of mass 2 kilograms, which recoils with a velocity of 1 meters per second. What is the velocity of the bullet? So we say the momentum of the bullet equals the momentum of the rifle. So mv bullet equals mv rifle. You've got to use the appropriate velocities in each case. And we notice that this is our unknown, the v bullet. So we're going to write that into our equation. And then we make a substitution. 0.01, that's the mass of the bullet. The unknown is the v bullet. The mass of the rifle is 2 and the velocity of the rifle is 1. You rearrange this, of course, we divide through by 0.01 to get the v bullet on its own. 2 times 1, of course, is just 2, so we divide through by 0.01, and the V bullet is 200 meters per second. And what we find is that the velocity of the bullet